question 1.1.1, we are asked to solve for x. So the first step we're going to do is we're going to factorize this problem here. So we're going to say x into 3x minus 4. So we are finding the factors of x squared, which is x. Then we factor it out, we equate to 0. So the solution here will be x being equal to 0, which is this 0 here, or 3x minus 4 is equal to 0. Then you transpose the minus 4 to the other side, we have 3x is equal to 4. Divide by 3 both sides, we have x is equal to 4 over 3. So the solutions for this problem here is x is equal to 0 or x is equal to 4 over 3. Now going to 1.1.2, we are also solved for x, but we are given a hint that our answer must be correct to 2 decimal places. So what you're going to do is whenever you are given the statement, it tells you that you cannot factorize this problem. So you're going to use your quadratic formula. So minus b plus or minus b squared minus 4ac divided by 2a. Our b in this case is 10, so it's going to be x is equal to minus into 10 plus or minus the root of, you write your 10 inside, squared minus 4. Our a, it's 3, and then our c, it's minus 4. Then you divide everything by 2 multiplied by 3, which is your a. Then the solutions that you're going to get once you simplify is minus 3.69. So this is 9. Or x is equal to 0.36. So these are your 2 solutions that you're going to find once you substitute everything inside. So remember that we must write correct to 2 decimal places. Now 1.1.3, we're going to solve for x for this one using the inequality sign there. So we're going to first transpose the 9x to the power squared to the other side. So we're going to have minus 9x squared plus 15x minus 4 less than 0. Then from here we're going to divide by negative. Divide by negative 1, divide by negative 1. We want to write the standard form properly. So we're going to have 9x squared minus 15x plus 4, because when you divide an inequality with a minus, the inequality sign changes. So this one was facing that direction. We divided it with a minus sign, it changes into a greater than. So it's going to be greater than 0. Then from here, we are going to factorize greater than 0. So you're going to find the factors of 9x squared, which is 3x and 3x there. And then we're going to look for factors such that they will give us the middle term, which is 15. So by putting 4 here and 1 there. So those are going to be the factors. When you multiply 4 with 3, 4 times 3 gives you 12. So if you add this 12 with the 3, it will give you 15. So those are the factors. Then you put a negative here and a negative here because the sign in the middle term is negative. So the bigger sign takes that sign. So you have that, your factors. Then you write your critical values. Your critical values, why? Because we having an inequality sign here. So the critical value is going to be 3x is equals to 1 or 3x is equals to 4. Then you divide by 3, both sides, you divide by 3 here. You have x is equals to 1 over 3 or x is equals to 4 over 3. So these are going to be your critical values for the problem here. So now what you need to do is you need to draw your number line. So let me draw my number line at the top where I'm going to introduce my or write down rather my critical values. So we have x being equals to 1 over 3 here, and then we have x being equals to 4 over 3. So these are my critical values, these ones. So this step now, because we want to conclude the values of x, we want to write the solutions of x. So for us to write the solutions of x, we need to go to this number line and test our number line. So what we can do is this. We're going to test values that are less than 1 over 3, this critical value here, which you can just say because 1 over 3 is 0.3333. So you can test -1 for an example, and then you test a value that is in between 1 over 3 and 4 over 3. You can say 1 because 1 is less than 4 over 3, your critical value. Then here you can test 3. So you need to test these values that I've circled, these values here. You have to test them for you to conclude your solutions of x. So what you're going to do is you have your equation. You have your standard form of equation, this one here. So you're going to write it wherever you want to write it in your piece of paper. Minus 15x plus 4. Then you're going to test. You say when x is equals to -1. So let's say we test this one here. So when x is equals to -1, you substitute. You're going to say 9 into -1 squared minus 15 minus 1 plus 4. So what we're mostly interested in here, we're not really interested in the solution, but we are interested in the sign that you're going to get when you substitute this value. So the sign that you're going to get when you substitute any value that is less than 1 over 3, which in this case we chose -1, you're going to get a positive sign. That is the sign. You can test any value. You can test -3, -4. You can test any value. It will give you a positive sign. So that value will be positive. Then you write that sign here. So you're going to write, so between 1 over 3 and -1, you know your sign is positive. All the values in between are positive. Actually, values that are going in that direction are positive. Then you do the same thing. You say, when x is equals to 1 now, because we are testing these ones. These ones that I've circled are the ones that we are testing. So we're testing 1 now. So you're going to substitute 1 in your original equation of 9x squared minus 15x plus 4. You're going to test. You're going to say 9, substitute. You put your 1 there, squared minus 15, put 1 plus 4. The solution that you're going to get when you substitute this value, you're going to get a solution of negative. Once you get that solution, you're going to go there in between your critical values, because 1 lies in between the critical value of 1 over 3 and the critical value of 4 over 3. So you're going to write the sign that you got, which is negative. You write it down, and then you continue. You test a value that is greater than 4 over 3. You say, if x is equal to 3, so we are using the circled ones, then you substitute 3. So 9 into, you put 3, where there's x, you put 3 plus 4. You only check the sign. What is the sign of the answer you're getting? You're going to get a positive sign. Then you take that sign, because you know that this value is greater than 4 over 3. So it's positive. So we know that from here to that direction, it's positive. From the critical value to that direction, is positive. But what does the question want? Now you go back to the question. What does the question want? You need to interpret the question. The question says that find values of x such that your solutions must be greater than 0. Why am I saying this? Here, just here. This inequality here says greater than, and it says greater than this 0 here. So you must find solutions such that they are greater than 0. When something is greater than 0, which means the sign is positive, we are more interested in solutions of x that are positive. So when we look at our timeline that we just did, you can see the direction of positive solutions of x. It's from this critical value going to that direction. You're going to get positive solutions of x. And then from this critical value going that direction, you're going to get positive solutions of x. So as I was explaining, when something is greater than 0, it is positive. So So this problem wants solutions of x that will give you a positive solution of y, basically. So meaning this is where you get positive solutions of y. This is where you get positive solutions of y. What are those values of x when you get those positive solutions of y? So you're going to conclude and say, therefore, when x is less than 1 over 3, when this x value, use the critical values to conclude. When x is less than 1 over 3, you are getting positive solutions of y. When x is less than 1 over 3. When x is greater, this time around, this one, when x is greater than 4 over 3, you're getting positive solutions of y. Or x greater than 4 over 3, you're getting positive solutions of y. So that's how you solve this inequality problem. So now we are going to do 1.1.4. We are having SATs. So this is solve for x but with SATs. So whenever you have a problem that wants you to solve for x with SATs, you should know that the solution at the end, you need to test it and see if it is correct, it is valid. So please note that. So we're having root of x squared minus 5 equals 2 root of x. So the first step we're going to do here is we're going to square both sides. So you square both sides, and then you have x squared minus 5 equals 2. So this squared will multiply any power that it finds inside. Any power that it finds. So you're going to have 2 to the power of 2 multiplied by x. So this x, this square root of x, is x to the power 1 over 2 like this. Then it's going to multiply by this 2, which is just going to be x. So you're going to have 2 to the power of 2x like that. If you write it properly, it's x squared minus 5 is equals to 4x. Right? Then you're going to write your problem in standard form. So it's x squared minus 4x. You transpose the 4 to the other side. Minus 5 is equals to 0. Then you have your standard form. Now you need to solve your x. So it's now simple. You find the factors of x squared, which is x and x. Find the factors of 5 such that they give you the middle term. So it's 5 and 1. And the 5 must be negative and the 1 must be positive. Then you say x plus 1 is equals to 0. Or x minus 5 is equal to 0. Then x is equals to minus 1, or x is equals to 5. So you need to test these solutions of x because you're having a SAT problem. So you need to test your solutions of x. So I did test my solutions of x. When you substitute, so you're having a root of x squared minus 5. When you test on the left hand side, when you put negative 1 here, because we're having the solutions of negative 1, you square it, then you say minus 5. What you're going to get here, it's going to be positive 1 minus 5, which is equals to the root of minus 4. So a root that has the negative sign inside, it's just doesn't exist, right? It's not real, right? So there's no solution for this one. So hence you're going to say it's not equals to minus 1. I mean, you can still put it inside this right hand side. The right hand side, you have 2 root of x, of which 2 root of your x is negative 1. So same thing happens on the right hand side. So the left hand side is not equals to, the left hand side is not equals to the right hand side. Hence this x is not equals to minus 1. Then you're going to test this 5 and you'll find that it's correct, but please test it and see if it is a solution of x. 1.2, we are asked to solve for x and y in this problem here. So they've really simplified it nicely for us, and please note that the marks, it's actually 3 marks. So when you check the marks, they tell you on how much you need to solve the problem, so it becomes easier to tell. So we're having this problem here and we're asked to solve for x and y. If you think about it, normally you'd have x maybe plus 1, x minus 1, for example, equals to 0. Well, how do you solve for x in this problem? You just say x plus 1 is equals to 0, or x minus 1 is equals to 0, right? Then you transpose x equals to minus 1, or x is equals to 1. So that's how you normally solve this problem. So the same concept you apply it here. So meaning that what's inside is going to be equals to this 0 here. What's inside the brackets, the squared brackets. So it's going to be 3x minus y is equals to 0, or x minus 5 is equals to 0. Then you transpose the y to the other side, you have 3x is equals to y, or x is equals to 5. So x is equals to 5, but what is the solution of y? We don't know, so we need to substitute x here. So you're going to say y is equals to 3 into 5. Therefore, it's 15. So the solution of y is 15. So that's how you solve for x and y in this problem here. Then now we want to solve 1.3. We are given this expression here, and we are told that whenever we see x minus 2, we must put y. So it's equals to y. So in 1.3.1 says that show that the given equation can be expressed in this form. So we know that y is equals to x minus 2, and the given expression is x minus 2 equals to minus 4 over x minus 2 minus 4. So we know that y is equals to x minus 2. So meaning instead of writing this x minus 2, I'm going to write y equals to minus 4 over y minus 4, right? Then we're going to multiply out this y throughout, multiply out this y throughout. So when you multiply out here, y multiplied by y is going to be y squared equals to minus 4 minus 4y. So we have to write this in standard form. So meaning you're going to take everything to the other side of the equation. So which means we're going to have y squared plus 4y. So it's plus 4y plus 4. So to write it properly, you have y squared plus 4y plus 4. So that's how we're going to do it. So now we are done with 1.3.1. You're going to 1.3.2. Hence, show that the equation has real and equal roots. So for us to do this problem, you must know your nature of roots. Nature of roots. Your nature of roots, if you have a discriminant that is less than 0, you know that is non-real. If you have a discriminant that is greater than 0 and is a perfect square, then you know your roots are real, rational, and unequal. If you have a discriminant that is greater than 0 and it is not a perfect square, then your roots are real, irrational, and unequal. If you have a discriminant that is equals to 0, then your roots are real, equal. They'll definitely be rational because they can be expressed as a fraction. So these are the nature of your roots. This is what you need to know for you to solve such problems. So here we are asked to show that the equation has real roots. Which equation? This one that we just found, that it has real and equal roots. So which expression should we use? We can use this expression here, this one, because the discriminant is equal to 0. When the discriminant is equal to 0, we have real solutions and we have equal solutions. So let's use that discriminant. It's going to be discriminant is equal to 0. We know, but the discriminant is equals to b squared minus 4ac. So what is our b in this case? It's this 4. So it's going to be 4 all squared minus 4 into our a is 1. Here it's 1. Our c is 4, which is this one here. So then you're going to have 16 here minus 16, right? Because it's 4 squared. It's going to give you 16 minus 4 times 4 is 16. So it's going to give you 0. So this is the solution of your discriminant. It's 0. Therefore, your your roots are going to be what? Are going to be real and equal. So that's how we solve this problem here. Now we're going to solve 1.4, which says that calculate the maximum value of s if s is equals to this expression here, right? So we're having s equals to 6 over x squared plus 2. So for this expression, the entire expression to be a maximum, which means the denominator must be less. So what do I mean by that? If you have 1 over 2 and 1 over 4, which one is bigger? Which expression is bigger? This expression is bigger because the denominator is smaller, right? And the denominator here is larger. So the larger the denominator, the smaller the expression, right? So our aim in this problem, it is to make the expression, the denominator rather, to be smaller for us to have a larger expression of s. So if you look, so how can we make this expression smaller? You need to look at which values of x can you substitute in this x squared. If you substitute x is equals to minus 1, or if you substitute x is equals to 0, or if you substitute x is equals to 1, I'm just testing these values. You can substitute any value you want. You can substitute x equals to 3, x equals to 4, any value. But remember that we want the denominator to be smaller so that we can get a larger value of s. So we want the largest value. We don't want just the large value of s. The largest value of s that we can possibly get. So if, let's say, for example, I try x is equals to minus 1, right? So s would be equals to 6 over 1, minus 1, sorry, squared plus 2. So the value I'm going to get is 6 over, so this minus 1 squared is going to be 1 plus 2, meaning it's going to be 6 over 3. So the denominator is 3 for x is equals to minus 1. Let me test for x is equals to 0, right? So s is equals to 6 over, it's going to be 0 squared plus 2. So meaning our expression is 6 over 2. So the denominator is 2, it's small. Let me test for x is equals to 1, right? So it's going to be s is equals to 6 over 1 all squared plus 2. So it's going to be 6 over 3 basically. So the denominator, so which denominator is smaller between these three x values that I've just tested? It's this x value. The denominator is 2. That is the smallest denominator. These ones are larger. It's 3, it's 3. So you can see that for me to get a maximum value of s, I need to substitute with the lowest or the smallest value of x to get the largest value of s. So our solution here is going to be s is equals to 6 over, so instead of substituting negative 1 or 3 or 4 or whatever value, you're going to substitute 0 because it's going to give you the smallest denominator. Hope I was clear. If I wasn't clear, please comment down in my comments section below and ask questions. I will answer you. So it's going to be 6 divided by 2 basically. So that's going to be a solution of s, which we know 6 divided by 2 is 3. So this is the maximum value that you can get in this problem here. So that is how we're going to solve this 1.4. Thank you. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.